Okay, to those of you who are at home, stay safe, look after yourself. Those of you who are here, I'm going to go through 5A, some questions. 5B and C is today's work. Is that all good? Beautiful. We have in chapter 5 looking at vector lines, directions of vector lines, and planes and equations of planes. We are suggesting that if this is the vector that describes where point P is, that point P will be along this particular line and it's going to follow that particular direction. R of T is the position vector for position P. But we can describe position P as being vector A plus some proportion of vector D. And that T isn't time, it's a proportion. So if T equaled 1, then P would be there. If T equaled a half, then P would be there, a half the length of D. If T was negative 1, then it would be over here, that distance, but in that direction. If T equaled 2, then it would be 2 lots of D's and P would be up over here.
Why is it based off of the little a vector? Why is it a plus 2b instead of that vector?
Because when it's in coordinate form, I can then express my OA plus some aspect of AB, because P is going to be along the lines of AB. So we're setting up this idea of having two vectors being added together that will give you vector OP.
We can be moved closer to the ball.
Pardon?
They want to be moved closer to the ball.
They want to be moved closer to the ball.
But then you can't see the calculation.
We can move it, I guess. Like,
Yeah.
Is that better? You can stay with it.
but the laptop is like in the way. No, okay. You can see.
That position vector can also be in terms of i's and j components, and that this will tell you the initial position, and this will tell you the direction that P is travelling, and that there is the D component that was here. So that's our D. That's the direction that AB is going in. That's the direction that point P is moving in. And that we can see that D just there. We saw this the other day. We can have aspects associated with the vector equation, A plus T times D, where T is any proportion. The parametric equation, X in terms of the parametric T, and the Cartesian form for 3 dimensions. You can't write X and Y, so it'll be in that form. And we looked at lines that are parallel, then D1 and D2 have to be parallel to each other. For perpendicular, then D1 dot D2 will give you a 0 if it's going to be perpendicular. Distance, we can use Pythagoras' theorem, or you can just scale product, and we can describe the segments. And we did those 5 examples, or those 7 examples in class the other day. I won't revisit that. So this is now 5B.
Okay, I'm gonna start a new video.